hello, everybody. I'm going to do a little bit different. I realize there's probably some folks in here that are relatively new to the control system security scene. So I thought I'd kind of go through at a fairly high level some of the basics, I guess, and then I'm going to leave you with some thought-provoking questions because I really want to get to the Q&A portion of this panel. So, a number of people this morning have talked about the fundamental differences between how we approach things on the IT side of the house versus the operational technology side of the house. Most of the people in the control system space tend to come from engineering backgrounds, whereas most of the people in the IT space come from business or computer science backgrounds. I think that the message here is it's imperative that we work together. And I think that you can learn so much by walking in another's shoes that, I'd encourage you, if regardless of which side of the business you sit on, make that journey over to talk to your colleagues on the other side to understand, well, how do you approach this? How do you approach this in the IT world? How do you approach this in the OT world? You can take an awful lot of the policies and the procedures and the practices, and you don't have to necessarily start from scratch, right? You can rewrite or tweak those to be applicable to whatever environment you're in, and at least then they're consistent across the enterprise. Seems to be a consistent problem. Here we go. Okay. We've seen this slide before. I think it was my friend Eric Byers here who, coined something like you walk into a plant and they say, oh yes, we have an air gap and we're completely isolated, and there's like a minimum of 16 different ways they can bring data in and out of that system. So even if there is an air gap, so to speak, you have to think about how media moves in and out of that system. There's some really interesting exfiltration techniques that go on. I watched a presentation at S4 earlier that was talking about changing the logic inside the PLC to make the RF signature of that PLC change so that you could, at distance, point an antenna at it and basically send the equivalent of Morse code. So you could send messages out of the PLC by changing what logic you were running in it. Put a big block move in here which occupied more CPU space, and the fundamental frequencies of that changed. There was another one that was talking about varying the loads on big server power supplies so that you could see those loads go up and down, and then using that as a modulation technique. So there are many ways to get data out of systems that are essentially very well protected and isolated. There's going to be a lot of presentations. I'm sure all the vendors in the exhibit area have solutions for that. But just because somebody, in fact, when somebody tells you that their system is isolated or air-gapped, then you should go, aha, that definitely isn't, right? If you own up to the fact that, yes, it's all connected and we have to manage how that is connected, that's kind of like the first step in the 10-step process, right? And if you get into this, there's many, many, many different methodologies to get in and out of these systems, right? Vendor laptops. How many vendors walk in with their configuration device, plug it into your network? Did you scan it beforehand? Is that laptop going through your security policy process? And I would tell you that it shouldn't be the vendor laptop, and the vendors will complain about this, but you should give them one of your own that's under your security policies and make them load their software on it. And then you should control that, check it in, check it out, and have a procedure. I was once at a government facility that went so far to say that, oh yes, we paint all of our laptops bright yellow that are eligible for connecting to that environment, and they have fairly drastic measures if they see something that isn't bright yellow in their facility. I won't go into those details, but okay, so that's kind of the basics, right? There are some challenges in this area, but as other people have said this morning, it's not a technology problem anymore. We do have solutions that work in this space. There are very interesting companies that are startup modes, and Eric will talk a little bit more about a specific application. It's not about the technology anymore. You can find the technology to fix any problem that you have, for the most part, in this space. It's about commitment and dedication to actually fixing the problem, and then going and finding and hiring the right human resources, to do that. So learn where those vulnerabilities or weaknesses are in your system, and then go through and apply the right technology, and more importantly, apply the right people. So let's talk about a few things just to get you thinking. One of them is insurance. So I know there's going to be a session later on this week in talking about the insurance, but I mean, I'm hearing insurance underwriters talking about how do they measure with some degree of fidelity the maturity, cyber maturity in the control system space. This isn't just general IT, credit card theft, record data breach protection policies, right? In the control system space, so they can set your premiums. I mean, most companies that actually manufacture something that have some sort of risk in their process. I came out of pulp and paper, so boilers, recovery boilers, we had extensive insurance policies there, and I remember as a control system guy, you had to sit down with the factory mutual guy and walk through and show them that every interlock worked, and that yes, you would in fact protect the environment, right? Well, now those same people are starting to ask, what's the cybersecurity profile of that system? And does that affect how much we're going to charge you for insurance? So the actuarial data does not exist yet for the most part, but insurance companies are very eager to understand how this impacts a company's risk profile. And then tie that to how does this impact decisions? I mean, as an engineering control systems guy, if the vendor wanted to set up a remote access connection or something, I mean, I was like, I don't know, a junior control systems person. I just told the vendor, oh yeah, go ahead, plug it in. Does the chief risk officer for the company know that you, in your junior engineering job, just signed up to put a complete pipe into the control system from the outside? I think in most cases they don't. So what I'm getting at is we're accepting the risk at much too junior of a level inside the company. These risk decisions should be made by the chief financial or chief risk officer of the company, where they weigh the risk of what does that remote access, what can that impact from the business's perspective to what is the benefit of having it. And I would argue that when you do those calculations, a lot of times you'll say, no, you shouldn't have remote access. You should pay somebody to get on a plane or in a car and drive out and fix it, even with the downtime or production loss. In some of these processes, that risk is certainly very, very high. Another concept that's coming about, and I think Andy Bachman's here and will speak about this as well, is using what we know about the cyber threat landscape and using what we know about sound engineering principles. Why aren't we designing into the upfront engineering ways to mitigate those cyber risks? I saw a press release or a tweet yesterday from Ed at Connexus, who's talking about basically building the security version of a process hazard analysis, right? Build these processes into our fundamental design criteria. And you may find in some of these cases that we don't have the techniques to do that. Well, that's okay. We know how to build new techniques and technology to fix these problems, right? So make sure that we design these things in from the beginning. Don't go and try to bolt it on from the end. If you were here last year or a couple years ago, I keynoted the ARC forum and talked about this concept, and I called it, go find the big red button. You need to go into your plant and find that one or two most critical safety functions and figure out if that can be manipulated through cyber. And I don't mean just a network connection or, that it's connected to the internet in some way. I mean, can an informed adversary with a supply chain intervention manipulate that function to cause it to fail? Think Triton, right? Trisis, Hatman. I like Hatman. That was my old team. More about that, why they called it Hatman later. But can somebody go into your safety system and manipulate it in such a way that it would prevent it from doing its job? If the answer is yes, I suggest then you need to go back and re-engineer it with some of these consequence-driven, cyber-informed engineering principles, right? Now, I know there's a lot of people that will complain and say, oh, Marty's talking about going back to relay logic and that sort of thing. No, that's not the only solution, right? There's other solutions. But ask those questions, right? Especially ask those questions of vendors that are promoting integrated safety and basic process control system platforms. Some are done extremely well, some not so well, right? And I think that you need to ask the vendors the hard questions about how do they implement this, how do they manage the cybersecurity envelope around this, and more importantly, are you following their implementation instructions, right? I mean, so many times we see in the field that it's the way we've implemented these systems that violates the security integrity. Anyway, that's enough for me. I want to get to the Q&A part. So hopefully I've caused you to think about some things you weren't before.